Okay, so where we left off yesterday is we had kind of described what a trig function was and what relevance it carried to physics. Today I want to concentrate on, okay, so how do we, what process do we need to go through if I have a triangle and I'm using these trig functions? And it's actually a very simple process. So my focus today is going to be called solving trig function or solving triangles. If I'm solving a triangle, then I'm finding all the information on it. Okay, so if I'm solving it, I want to know what's the length of every side, what's the measure of each interior angle. Okay, so to solve a triangle, we want to first look at the triangle and find which side I have labeled and which side I have missing. Okay, so maybe if I'm looking at the homework example, this first one I had a 5 and an x. Okay. Then if I can identify the trigonometric ratio that addresses those sides, then I know a good starting point. So looking at this first homework example, I have a 75-degree angle here. Okay, from the 75-degree angle, I see 5 is the what side? Adjacent. Okay. 5 is the adjacent side, and x would be the hypotenuse. Okay, so which trig function is going to address the adjacent side and the hypotenuse? The cosine. Okay, so cosine addresses adjacent side and hypotenuse. Okay, so once I identify which trig ratio or identity I need, then I can insert the information into that trig function and then just solve for the unknown. Okay, so that and so where we left off yesterday was SOHCAHTOA, and so let me do an example. Okay, so if I'm solving a right triangle, I want to know angles A, B, and C, and I want to know sides A, B, B, C, and CA. Okay, so that's going to be all the information that that triangle has, and so we can start just by filling in the information that I know. I know angle B is 90. I know angle C is 37. And side CA is 19. The next step I follow when I'm solving is I look where I see two sets of information. Okay, so here I see two angles. Okay, so that I'm going to start with angles. So wherever I see two pieces of information, that's where I start. So if I see two angles, I'm going to start with my angles. And so I know that the interior angles of a triangle always sum to be 180 degrees. So therefore, since I have 90 and 37, I know that angle A plus angle B plus angle C should be equal to 180. So therefore, angle A is going to be 53. Okay, so there's my first bit of information that I surmised from the triangle. Y'all know this, right? Super easy. All right, once I do that, once you get, you really have a cheat, okay? When you use the two pieces of information, you're either going to use Pythagorean theorem to cheat, or you're going to use the sum to be 180 cheat, okay? Once you've cheated, then we have to use trig functions, okay? So we're done cheating now, and so we want to look at this, and I'm just going to choose to solve for BC first, okay? So if I'm solving for BC, first tip, never use a number that you've calculated to calculate another number. Okay, so we calculated 53, so I'm not going to use 53 because 53 could be wrong. Okay, so that's a bad start. So I'm going to use the 37-degree angle. Okay, so from 37, I know that AC is 19. AC is called the what side? Hypotenuse. And from the 37, I have BC, which is the adjacent. So which trig function do I need? Cosine. Okay? So I know that the cosine of 37 degrees is equal to the adjacent over the hypotenuse. Okay, well my adjacent is BC, and the hypotenuse is 19. Okay, so if I multiply both sides by 19, then I get that BC is 15.17. Super simple, right? Now we have another cheat from there. we could use Pythagorean theorem and get AB. Okay, but should we use Pythagorean theorem to calculate AB? No, why not? Because I'm using a calculated number to calculate another number. Okay, so first of all, 15.17 is rounded, and so that introduces error into the system. And second of all, 15.17 could be wrong, and so I don't want to use that. Okay, so to calculate AB, okay, I'm just going to use that same 37-degree angle. Okay, AB is the opposite side. Okay, so I want to use sine. Okay, 19 is the hypotenuse. So I know the sine of 37 should be equal to AB over 19, and so therefore AB is 11.43. Nothing new there, right? Any questions? I'm going to work another one, I think. Y'all be working with. All right, let me see if there's one. Yeah, cool. Yeah, I'll work another. Ooh, so slow. No, stop it. When this thing's recording, it moves at snail's pace. Okay, so let's say I have this this triangle here. All right, so we'll call this A, B, and C. We'll make this a 42-degree angle. We'll make this side 11, and so if this side's 40, if this angle's 42, we know that this one's 48. Okay, so let's go through and fill out my information. I have A, B, and C. I have AB, BC, and AC. That's all the information I'm looking for. And so let's just fill in the things we know. I know angle A is 48 degrees. I know angle C is 42 degrees. And I know angle B is 90 degrees. And I know BC is 11. Okay, so I gave you a little bit more information there than I did last time, but who's counting? All right, so let's just start with AB. Okay, if I'm solving for side AB, that's this side right here, I can use either one of these angles. It doesn't matter. I'm just going to choose 42 because I like 42 better. And so if I'm using 42, I have side BC, and I'm looking for AB. Okay, so from 42, that's the adjacent side and the opposite. So I want to use tangent. Okay, so I know that the tangent of 42 is going to be equal to the opposite over the adjacent. So in other words, it's going to be equal to AB over 11. Okay, to solve for AB, I need to multiply both sides by 11. Okay, so therefore I know that AB is going to be 11 times the tangent of 42. I want everybody to type this on your calculator and make sure you get the same answer as me, because your calculator will get a little bit mad if you have it in radian mode, so I want to make sure everybody's in degree mode. Okay, so I know that AB is 9.9. Has to be in degree mode. Okay, if you have one of the graphing calculators to get to that, I think there's actually a button that says mode. Yeah, and you can change it to degree mode under there. If you have another calculator, I can't help. You want it to say DEG somewhere. Everybody get a 9.9? Okay, the next step is, or my last step, is to solve for AC. AC is the hypotenuse. Okay, so if I'm using the 42, then this is the adjacent side and the hypotenuse. Okay, so if I have the adjacent side and the hypotenuse, then that's going to be the cosine. Okay, so I know the cosine of 42 should be equal to the adjacent over the hypotenuse, in other words 11 over AC. How do I solve for something in the denominator? Multiply both sides by that and then divide, or you could reciprocate both sides and then multiply by the 11. It doesn't matter, whatever floats your boat. I'm going to multiply both sides by AC. It takes the same number of steps either way. And then divide by cosine of 42. And so therefore AC is 11 over the cosine of 42, or 14.8. Lastly, I would advise checking your answers, because based on these, we know that the angle opposite of the hypotenuse, or angle opposite of the 90 degrees is the hypotenuse. That side should always be the longest, and so if that's not the longest, you know you've done something wrong. And then the next longest should be opposite of the next biggest angle. The next biggest angle is 48, and so that should be the 11. And then the smallest should be opposite of the smallest angle, 42, and that's 9.9. Okay, so that's a good way to check and make sure you've done, that's done some things right. Eh? Super easy? Okay, so that was the that's the case where I have interior angles and I'm solving for exterior sides. Okay, so I'm using trig to find the length of the sides. Okay, we can also use trig to find the measure of the angles. Okay, and so if I'm going to use trig to find the measure of the angles, then I'm going to use an inverse trig function. Back. Oh, okay, there we go. Let me skip through all this. We already did this. This took a long time to put together, by the way. All right, so inverse trig functions. All right, so regular trig functions solve for what? Sides. Okay, inverse trig functions are going to be used to find angles. Okay, so if I have an unknown interior angle, then I'm going to use inverse trig functions. Okay, so an inverse trig function, essentially what it does is, when we set up our equation, it's just going to take what's inside of the parentheses and what's outside of the parentheses and switch them. Okay? And that's a pretty fancy little animation I put together there. I was patting myself on the back on that one. Did y'all see that one? Okay, hold on, I'll do it again. Bam. What?
It's real nice.
Yeah. I sometimes spend way too much time doing this sort of thing. All right, so you notice now I have my angles on the interior of the function, so I'm not solving for angles because I can't get it out of there. And I have my, my sides, on the interior, and I have my angle on the exterior. Okay, so this will allow me to solve for the measure of an interior angle. All right, when am I going to have to use inverse trig functions? When I don't have what?
When you don't have angles.
When I don't have two angles. If I only have the 90-degree angle, if the only thing I have is the 90-degree angle, then inverse trig functions is what we're going to have to use. Okay, and if I already have two of the angles, I'm just going to use the whole supplementary thing. Okay, so I don't need inverse trig functions there. Okay. All right, so let's. What is this doing? I don't remember that. Why was I doing that? Don't worry about that. Maybe I was gonna. use this as an example. Hey, let's use this as an example. Okay, so let's say I want to solve for the interior angles here. I have a triangle ABC. I know. I'm copying it first. All right. So if I have a triangle ABC with the following dimensions, then I can use inverse trig functions to get those interior angles. Okay, so I know that I know that B is 90, I know that AB is 22, I know that BC is 16. Okay, remember I said always start off where you have two pieces of information. Over here I have two pieces of information on the side, so I'll begin by using the Pythagorean theorem. Okay, so I know that C squared is equal to A squared plus B squared. And that's kind of confusing with these A, B's, and C's. Okay, but C is representing the hypotenuse, and I'm solving for the hypotenuse. So therefore, the hypotenuse length is going to be the square root of A squared plus B squared, or 22 squared plus 16 squared. And y'all have done Pythagorean theorem a million times, right? Okay, so I know that the length of my hypotenuse is 27.2. Does that number make sense for the length of the hypotenuse?
Yes.
Why? Because it's the biggest one. Okay, so that makes sense. All right, now to get my interior angles, I can't add and subtract and do any fancy trickery. Okay, I'm going to have to use inverse trig functions. Okay, so here I see I don't want to use this 27.2 because it's calculated, so I'm going to use the ones that are included. So I'll start with angle A. So to get angle A, the relationship between these two sides is the opposite side and the adjacent side, right? So that's going to be tangent. Okay, so I know that the inverse tangent of the opposite over the adjacent is going to be equal to angle A. Okay, so notice how there I just took the numbers, I took the equations and flipped them around, and that's inverse tangent. So therefore, angle A should be equal to, and please type this in your calculator and make sure your calculator is doing it correctly, inverse tangent of 16 divided by 22, or 36.0. I kind of like 3 sig figs. They make me happy. So
What's arc sine? Is that the same thing?
arc sine. Let me think. It's been a really long time since I've heard that. Arc. Just try it.
I just heard the term.
I'm gonna have to look that up because I don't remember.
That's the same thing.
Is it the same thing? Arc sine? Okay. I aren't sure. Oh, that was bad. All right, the next one, solving for angle C. Okay, I know that for angle C, I could use the whole adding, subtracting thing, but we don't want to use that because that's a number that I calculated and could be wrong. And plus, if I calculate it twice, then I can check my answers right. And so for angle C, I'm also using inverse tangent. Okay, so the inverse tangent of 22 over 16. And so I get, it's equal to 53.0. 54.0, sorry. And so 54.0. And so they're right because those two add to be 90. What time is it? Okay. Don't you rob that minute from me. Okay, super easy, right? Y'all done that before in like geometry and and trig, and I'm sure you did that a lot in trig.